Today's video is talking about rational expressions and how to simplify rational expressions, how to factor them, check to see if two rational expressions are equal to each other or not. That's really what this video is going to be about. But before we start with that, what is a rational expression? And the definition I wrote here is an algebraic expression that can be written as the quotient of two polynomials. Quotient, if you remember, means division. So two polynomials divided by themselves, or a polynomial divided by another polynomial, is called a rational expression. So an example is 5 over x minus 7 is, or x plus 7, doesn't really matter, plus or minus. This is a rational expression. You got a polynomial divided by a polynomial. Another one could be x squared plus 4x plus 2 divided by x plus 2, or x plus 1. That's also a rational expression. It could be negative a to the fourth over 7b squared c. All of these are rational expressions. It is a polynomial divided by another polynomial. It's the quotient of two polynomials. That's what a rational expression. Now, let's talk about the domain of these. When we ask you what is the domain of the rational expression, for example, if I write this problem, I say find the domain of 5 over x plus 7. That means find the x values, that if you plug them in, you will have an answer to this rational expression. Well, the only time that you will not have an answer to a fraction is when the denominator is 0. So if we take the bottom and set it equal to 0 and solve it, and remember, change side, change sign, take that plus 7 to that side, x equals negative 7. So my domain for this problem is x does not equal to negative 7. It can't be negative 7. And why is that? Well, what will happen to this expression, to this rational expression when x is negative 7? What will happen to it? Well, the value of that will be 5 over negative 7 plus 7. What is negative 7 plus 7? It's 0. 5 divided by 0 is undefined. That's why we're saying x cannot be negative 7. That is the only value in the world that will make the bottom of this fraction equal to 0. Nothing else will make this equal to 0. So my domain is actually all real numbers except the negative 7. Well, we're not going to write all real numbers except negative 7. We're just going to say x does not equal to negative 7, which means all the numbers but negative 7. So let's take a few of them and go through them and see what the domain is. Find the domain of 8x over x squared minus 3x plus 2. Find the domain of that. Remember, I said I need to find out what value or values. It might be more than one. That will make the bottom 0. So let me take the denominator here and find out what are the values that will make it 0. What are the values that will make that 0? Well, if you remember, this is solving a quadratic equation. We did that maybe 2 videos ago. We said move everything to one side. We do have everything on one side. Factor completely. Let me factor that. In case you forgot your factoring, notice this sign is positive, which tells me both signs are the same as this one. They're both going to be negative. And I need to figure out what the two numbers here are. So here's the plus 2. Let me list the factors of plus 2 and the sum. Well, the plus 2, since both numbers are going to be negative, is actually negative 2 times a negative 1. That's the only way to get a plus 2. And when you add them, that's a negative 3, and that's what you want it to be. So the two numbers are negative 2 and negative 1. Remember, move to one side, factor completely, set each factor equal to 0 and solve it. And you take the negative 2 to that side. When you take it to that side, x becomes what? 2. When you take the minus 1 to that side, x equals to what? 1. So my domain, when I write that problem, will say x does not equal to 1 or 2. X does not equal 1 or 2. Let me try another one. Find the value or values that will make the following rational expression undefined. Find the value or values that will make the following rational expression undefined. I'll do 2 of them. I'll write 2 of them. One of them is c plus 5 over c minus 9. And the other one, since there's more than one, the second one we'll do, I don't know, 4 over t squared minus 16. So let's look at the first one. Let's look at A. So what value or values will make this rational expression undefined? Is, in this case, there's only one value, is the value that will make the bottom 0. So take the bottom, set it equal to 0 and solve it. Take the minus 9 there. So that will give me what? C equals to 9. So you want to make sure that C does not equal to 9. Or what value will make the bottom 0? We say the answer is 9. So if you want to answer their question, you go C equals to 9. The 9 is the value that will make this expression undefined. If you want to write the domain of that, the domain for the expression, we say x does not equal to negative 9. That means all the numbers but negative 9. Now let's look at B. 4 over t squared minus 16. Now I can factor t squared minus 16. And that's the difference of two squares. Remember, that's t squared minus 4 squared, which when you factor that, that's t minus 4, t plus 4. So what are the values that will make this expression undefined? Are the values that will make the bottom 0. So take the bottom and set it equal to 0. And for that to be 0, set each one equal to 0 and solve it. When you take the plus 4 there, take the negative 4 there, you have t equals to 4, t equals negative 4. So these are the two numbers that will make this expression undefined. So my domain, if I want to write the domain for that, what x values can we use? We're saying all the or t values, all the values that t cannot be negative 4 or plus 4. Let's look at equivalent expressions, because we're going towards simplifying, but let's stay with this for now. Equivalent expressions. Now, let me ask a question. Let me give you two expressions and tell me if they are equal or not. Is 2 over 3 and 2x over 3x equivalent? Are these two equivalent? And the answer is really yes. Why? Because if you take the 2 over 3, that's a fraction. If you multiply the top and the bottom by the same thing, you will not change the value of that fraction. So if I multiply the top and the bottom by x, what are you going to have? You will have 2x over 3x, which is that one. So 2/3 and 2x over 3x are equal because all we did, we multiplied the top and the bottom by the same thing. Again, anytime you take a fraction, you multiply the top and the bottom by the same thing, you will not change the value of that fraction. Hopefully x does not equal to 0, because if x equals to 0, we get 0 over 0. We know that's a problem. But we're going to overlook that 0. Let's try another one. Is let's see. D minus 5 over 3 and 4d squared minus 20d over 12d, are they equivalent? So here is the first one. The question is, how am I going to change this to make it look like this? Well, let's look at the bottom. That's an easier one. How do we turn the 3 to 12D? How do we make a 3 12D? Isn't that if you multiply it by 4D? What's 3 times 4D? Isn't that 12D? So let's see, if you multiply the bottom by 4D, that means you got to multiply the top by 4D. And let me simplify that and see if the result will produce that one. If it does, they are equivalent. What's 4D times D? 4D squared. What's 4D times a negative 5? Negative 20D. The bottom. What is 3 times 4D? 12D. Is this the same as this? Yes. So are these two rational expressions equivalent? The answer is yes. You could actually work the problem backward. We could have started with this, try to simplify it to see if that's equal to that, instead of doing it this way. So I can tell you if they are equivalent or not, either by multiplying or by simplifying. Again, what do I mean by simplifying? Let me take the same example. There we go. I'm going to do the problem differently here. Is 2 over 3 and 2x over 3x equivalent? We know the answer is yes. We just did that. We took the 2 over 3, we multiply the top and the bottom by x to make it look like this. Now I'm going to work it backward. I'm going to start with this and see if I can reduce that to this. So let me take that 2x over 3x. What the 2x means is 2 times x. And the 3x is 3 times x. And if you remember, as long as you have the same thing on the top and the bottom, you can simplify that. So you get the x on both the top and the bottom. They will cancel each other out. And what's left in this one? 2/3. Is that the same as this? Yes. So that's another way of seeing if the two rational expressions are equivalent. You take the bigger one, you try to simplify it, see if you can change it to the smaller one. Let's apply the same logic for the other problem. Is d minus 5 over 3 and 4d squared minus 20d divided by 12d equivalent? And let me take the bigger one, which is this one, try to simplify it, see if I can change it to this. And with the method I'm going to use is factoring, and that's what I kept saying the last videos. Factoring is so important for us. Because again, if you're still weak on factoring, you're going to struggle here. So hopefully you spend some time on factoring and you got it. Now let's look at the top. What is the greatest common factor? The 4 and the 20, what do they have in common? They both have 4 common. And what about the d's? This one has 2, this has 1. There's only one d left here. So the 4 is gone. D squared, there's 2 of them. You took 1 outside, there's still a d on the inside. Here's the minus. What's 20 divided by 4? 20 divided by 4 is 5, and we took the d out. That's what's left there. Now the 12D, I'm going to write the 12D 3 times 4D. Why 4D? Because I'm hoping I can cancel the 4Ds. Notice I got 4D on the top and the bottom, and as long as you have the same thing and you have multiplications, you can cancel them out. So what's left? D minus 5 over 3. Is that the same as this? Yes, it is. Are they equal? The answer is yes. We're going to use this logic to simplify a fraction because that's a simplified version of this. So let me ask you to simplify a few of these problems. Go through them and see what the answer is. Simplify. (10x squared) over negative 5xy. Now the 10 and the 5. Let's see. I can write the 10 as what? 5 times 2. That's a 10. And x squared is what? X times x. Why did I choose 5? Well, that's the only option, 5 times 2. But also my other reason, I was looking for this negative 5. What is negative 5? It's negative 1 times 5 times x times y. And as long as I have the same thing on the top and the bottom, I can cancel them out. The 5s will cancel. What else cancels? The x will cancel. So my answer is what? 2 times x, which is 2x, over negative 1 times y. Usually they're not going to put the negative here. What is 2 divided by negative 1? That's a negative 2. Negative 2x over y. And some people like to put that minus in the front instead of on the top. So you can write it this way also. Let's try another one. Simplify. Negative 4 a squared b cubed over negative 2 a b squared. So the negative 4 can be written as negative 2 times 2. A squared is a times a. B to the third. I can write it b times b times b, or b squared times b. Because when you multiply, remember, when you multiply, you add the exponents. That's a 3. I don't want to write b times b. Like, why break it down that many times there? And the negative 2, that's negative 2 times 1 times a times b squared. And let's look for the same thing on the top and the bottom. Here's the minus 2 with the minus 2. There's the a with the a. There's b squared with b squared. So what is left when you simplify that? I have a 2 a b over 1. Well, if it's over 1, you don't put the 1, 2ab. Let's make the problem a bit bigger now. 3x minus 6 over 9x plus 12. Factor. Well, let's look at the top. The greatest common factor for the top is a 3. If I take a 3 out, what is left? There's x minus, what is 6 divided by 3? That's a 2. The bottom for 9 and 12, which is what? That's also a 3, that's common. What's 9 divided by 3? There's 3x plus the 4. And notice I see a 3 common to both of them on the top and the bottom. I can cancel that, and it's x minus 2 over 3x plus 4. Can't simplify that anymore. You can't cancel this x with that x. It has to be, this is one thing. The whole thing is one piece. The x minus 2 is one piece, and the 3x plus 4 is another one, and they're not the same. So I can't cancel them out. Simplify. T plus 6 over 2t plus 12. I can't really do anything about the top. Stays t plus 6. Can't simplify anything. But the bottom, if you look at it, there's a 2 that's common to both of them. If you factor a 2, what's left here? There's a t plus, what's 12 divided by 2? That's a 6. And if you look closely at it, this one is really t plus 6 times what? Times a 1. We just don't put the 1. But I want to put the 1 because I want you to see it. And notice t plus 6 is the same for both of them. You can cancel that out. And what's left? So when you cancel the whole thing, there's always that 1 there. A lot of people don't want to put the 1. There's a 1 there, but we just don't put it. But in this case, you have to write the 1. If you just write the 2, that's the wrong answer. So it's 1/2. How about this one? N plus 4 over n minus 4. Well, here's the good news. There's nothing you can do to simplify this or factor it, neither this one. You can't cancel the n's. They're together. So in this case, the expression cannot be simplified. You can't simplify this. Cannot be simplified. Let's make them a little bit bigger. Simplify. XY minus XZ over xt minus, or I'll make it a plus, 3xg. Again, let's look at the top. Do you notice anything common on the top? You can factor out the greatest common factor. I see an x on the top. Let's look at the bottom. I also see an x in the bottom. So if I factor an x out, what's left there? There's the y minus the z. If I factor an x, what's left? T plus 3g. Notice the x is common to both of them. It's gone. And my answer is y minus z over t plus 3g. Simplify. Four n squared minus 4 over n squared plus 3n plus 2. Again, you need to factor each one of them if you can. If I look at the top, I can factor the top as what? Take a 4 out, and what's left? N squared minus the 1. Am I done factoring? No. The 1 is actually like a wild card. You can write the 1 as 1 squared. What is 1 squared? Still a 1. But the reason I wanted to write it like this, now I can use that special method, the difference of two squares. This will be 4 n minus 1 n plus 1. Now let's look at the bottom. Is there anything common here to factor out? The answer is no. N squared, that means what? N and n. And this sign is a plus. That tells me both signs will be the same as this one. So they're both going to be positive. And the 2 is 2 times 1. And that'll give me 2n plus 1n. That's the 3n in the middle that I need. So if I write that here, I'm assuming you know how to factor by now, so I didn't spend too much time factoring this. And notice n minus 1 will cancel that. So what's your answer? 4 times n minus 1 over n plus 2. That's a good answer. You can leave it like this, or if you don't like leaving it like this, you can actually multiply it through and write the answer as 4n minus the 4 over n plus 2. Either one is really correct. So I'm not sure which way the book wanted the answer written. Just preference. Some people like it this way, others like it that way. Let me try another one. Simplify. Two y squared minus y minus 1 over 2y squared plus 7y plus 3. Again, I need to factor each one of them. Look for the greatest common factor. Nothing. So let me try to see if I can factor that quickly here. I know that 2y squared is 2y and y. This is the one. One is positive, one is negative. I'm not sure which one because the sign is different. That tells me one of the signs is positive, one of the signs is negative. This is the negative, this is the positive. How would I know? That gives me 1y. This gives me negative 2y. What is 1y minus 2y? That's the negative y that I need. Now this one, 2y, y, the 3, positive, tell me both signs are the same. They're both going to be positive. Here's a little hint. If you're not sure what to write, where to put the 3, where to put the 1, most of these problems, they're going to make it try to cancel out. If I put a 3 here and the 1 there, nothing is going to cancel. So let me try put the 1 here and the 3 there. And let's see if we have the correct one. What is 1 times y? 1y. What's 3 times 2y? 6y. So what's 6y plus 1y? That's a 7y, and that's correct. I knew that, like I had a feeling that these two are going to be the same, so I can cancel them out because the same thing on the top and the bottom. And my answer is going to be y minus 1 over y plus 3. So you're going to see me cheat in a way, try to use that logic that the two of them going to match when I'm factoring and trying to see if that'll be a quick way to get to the answer. Let me try maybe a few more questions here. Simplify negative 5x minus 5 over 1 plus x. Notice on the top, I can factor a negative 5 out. If I take a negative 5, that's negative 5 times x, and that's negative 5 times 1. So what I have left is x plus 1. I'm factoring the minus out. Notice that's negative 5x. Negative 5 times 1 is negative 5. The bottom is 1 plus x. Well, when it's addition, if you write 1 plus x or x plus 1, it doesn't really matter. If it's subtraction, it's a different story. But addition, that's the same thing. And you can see this one, x plus 1 and x plus 1, they cancel each other out. And my final answer is negative 5. Let's simplify 3x minus 12 over negative x plus 4. The top, I can factor a 3 out. If I take a 3 out, what's left? X minus the 4. The bottom, I can factor a minus 1 out. because the minus sign, I'm taking the minus 1 out. What's left there? X, and this becomes a minus 4 again. Because you're taking the minus 1 out. What's minus 1 times x? That's a negative x. What's a minus 1 times a negative 4? That's a plus 4. So when you factor a minus sign outside, you got to change the sign of this. That becomes a plus. You got to change the sign of that. That becomes a minus. And you can see there's x minus 4 in both of them. That is 3 over negative 1, and 3 divided by negative 1 is negative 3. Let me make this 4x minus 20 over 25 minus x squared. Again, when I look at that, I can make that 4 times x minus the 20 is 4 times 5. 25 is actually 5 squared minus the x squared. You can see there's the 4 common factor on the top. So what's left? X minus the 5. The bottom here, this is the difference of two squares. It's 5 minus x, 5 plus x. There's one little problem here, and that is this is x minus 5 and this is 5 minus x. They're backward. Not like this. Addition is not backward. Addition is the same, but subtraction, these are backward. And you can still cancel them, but the result, you have to change the sign to a negative 1. So this becomes, what is 4 times a negative 1? That's a negative 4 over 5 plus x. As I said, a lot of people will write that negative 4. I like x first. So I like it better this way, but it really doesn't matter, just my preference. And others even like the minus sign to go on the front. Any one of these answers is good. It's just, which way do you like it? Do you like it like this, or like that? Not one is not better than the other. We'll do one more. Four minus 9x squared over 3x squared plus x minus the 2. Now again, I can write the top as 2 squared, because I'm trying to make it the difference of 2 squares, and this will be 3x, the whole thing squared. And when you factor the top, it's going to be what? 2 minus the 3x, 2 plus 3x. The bottom, notice the leading coefficient is different here. So let me start with 3x and x and see if that will do it. The negative 2, that means the signs are different. One is positive, one is negative. Notice this is 2 minus 3x. This is 3x. Maybe the minus 2 will go here, and the plus 1 will go there. Let's see if that's correct. What's minus 2 times x? This is negative 2x. This is plus 3x. What's plus 3x minus 2x? That is plus 1x, which is what you want. So we did factor the problem correctly. Now I have to look for the same thing on the top and the bottom. These are not the same. They're close, but they're backward. So it's a minus 1. So my answer is going to be minus 1 or minus 2 plus 3x over x plus 1. If you want the minus in the front, instead of the top, that's fine. Me personally, as I said before, I like to write everything in descending power. That top bothers me. Nothing wrong with it, I don't like it. That will be a minus, and I will make that 3x plus 2. Notice it's a plus, so if you switch them, that's okay. Over x plus 1. And that will be my final answer.